Well, hello everyone. Good morning, good afternoon, good evening, wherever the world you are. Welcome to another session with Microsoft Hero. So excited to launch today's session together with my very own best friend Shahab Ganji, and with the topic of create a Tic Tac Toe game and learn about event sourcing. So welcome again. I'm not going to take that much of session's time. I will quickly talk a little bit about the community, Microsoft Learn, and also code of conduct we have for every session. So Microsoft Learn, I always try to share in every session and in every community session conference, make it your homepage. That's kind of what I really believe, like making it in my homepage, in my mobile devices, tablet, my laptop. Just every time I open it, I always learn something new. Can be every day, can be multiple times in a day, or multiple times during a week. But it is true. It's we are all on the same ship, learning about Microsoft technologies, and this is the exact source that we need to refer to where to learn about Microsoft technologies and how to level up actually with Microsoft technologies. From customizing your own training and learning path, from taking exam and test practices, certifications, apply the skills, joining to community rooms, to learning rooms, and connecting with professionals from all over the world, and of course also with fellow learners from the community. We are all learners. Learning never ends, and again, we all go back to Microsoft Learn again to learn even more and more on a daily basis. So make it your homepage, follow the community news, and follow sessions, and stay up to date. Last but not least, code of conduct, being aware of each other, being friendly and patient, welcoming and respectful, opening to all questions and viewpoints, understanding differences, and being kind and considerate to others. With that said, I'm gonna add Shahab to the stage. Hi, Shahab.
Hi guys,
How are you
how are
today?
you? I'm well. I'm good. Thank you. How are you?
I'm great. Thank you. So since we are both in the same time zone, so good evening.
Yeah. Good evening. I hope everyone, regardless of where they are in this blue planet, they are all having a great time. And yeah, here is evening, and actually, yeah, I'm looking forward to the weekend.
Yes, it's gonna be a good weather, I guess.
Yeah, yeah, it is. It is.
So I'm gonna bring up your slides and I will leave the stage for you.
Thank you.
Good luck.
Thanks. Yeah, glad to be here. We want to talk this evening about event sourcing, and I want to start with domain-driven design because I really like domain-driven design, and what I really like about it the most is ubiquitous language as unbounded context. I really like these things, like to the extent that I sometimes, when my kids also wants to tell me something about the school or their daily stuff, I need them like to put some context around it. You may ask why I'm doing that. Because I believe context matters. Context is king, and it helps us to understand every situation better. It helps us to be able to better communicate with one another, and being able to describe what is going on around us without having stress, or without using different languages, because one word could have different meanings in one context, right? And it is important to understand each other better and avoid serious misunderstandings when we are talking to each other. So that being said, I really want to have a context in here for the whole session. So it is about event sourcing, and let's talk about what it is not about. So we have event storming in the community as well. This is a collaborative modeling approach that you could use and employ that to design and understand your system, and being able to figure out what's going on around the system that you want to design. So this session is not about event storming. it's also not about event modeling. It's also event modeling is also another approach that you could use to create a design for your system to have a better understanding what's going on, what are the workflows that you need to implement, and all of those things. And even though these two approaches are very good with event sourcing, this session is not about. Another thing that this session is not about is event streaming. The event streaming is an architectural pattern that you could employ in your overall system to put your data in motion and send the data between different subsystems or different domains or different bounded contexts, if you will, and sync the data between those things. So put your data in motion. So event sourcing is not also about that. And what the last thing that this session is not about is we're not going to be masters of event sourcing after this session. This is about learning the building blocks, how it works, the concepts around that. And then we need to dig deeper into the topic and learn more about it. This session is about introducing a tool in your tool belt. So next time that we want to design a system, we have another approach in our toolbox that we could employ. So with that said, I'm Shahab, the guy who happened to be a software engineer 20 years ago. I'm still enjoying this journey. And I'm a software architect and software transformer at Square, which is a company based in Vienna and Munich. And we are helping our customers to transform their softwares. I'm a .NET and C# enthusiast, a DDD and event sourcing practitioner, definitely not an expert in any of those things that I just named. And since change is the only constant in this world, I'm embracing it heartedly, full-heartedly. And I'm also a father of 2 amazing kids, so it is expected of me to tell dad jokes. So if I said something in this session, just drop some lol emojis in the chat, because if you don't do that, it hurts my feeling, and I don't like that. So I'm also a Microsoft MVP and a community leader in Microsoft MS Farsi community and Microsoft Zero to Hero. In my leisure time, you could approach me on social medias, LinkedIn, Blue Sky, GitHub, and sometimes I'm creating YouTube videos and also writing articles about things that I learned the hard way. Okay, so we said a lot of things about events. So what it is and what is it not, but let's see what is an event. Event is a business fact that has happened in our system, and we cannot change that. It's a fact, it's immutable, and it belongs to the past. So we cannot change them. In the context of creating the Tic Tac Toe game, we could think of a couple of events. So we could have a game created by some players, and then 2 players could join the game. So players joined, and those cells, if they are marked with X and O, we could call that a cell field. And after a couple of moves that are played with the players, we would have a game finished, whether there is someone win the game or someone lose the game, or the game is a draw. So these are the events that we are going to do. In the book Designing Microservices, Building Event-Driven Microservices, from Adam, he mentioned that there are different type of events. One of them is an on-keyed events. These are the events that are just happening. They are not related to each other. More like telemetry data and things like that that we are storing in our system. Then there's another type of event, which is entity event. And the entity events are always holding the state of the entity that this event has happened for them, and storing all properties, all data related to that entity in the event, right? And then there's another one, which is keyed events. These events usually have a key, and this key is not necessarily the key of an event, but it is used to organize a series of events, streams of events, partition of events, group of events, whatever you want to name them, together. So we could process them together, and we could store them maybe in locality, because when we want to fetch them, we need all of them. And this slide is a little bit controversial, because some DDD practitioners do not like to differentiate between the events of your system, right? Because as we said earlier, event is something that belongs to the business, to the domain context that you are designing. So it doesn't matter which type it is describing something in our system. It is important to think about them as business events. This is very important in our contexts. So when we are designing event-driven architecture, it is very easy to publish everything as an event. And by everything, let me give you an example. So the other day, my family and I were sitting at the dining table, and we had lunch together. And during the lunch, my wife mentioned that we didn't have coffee today. And well, the kids just ignored what she said, and I was like thinking about that. Okay, yeah, honey, we didn't have coffee, but after like a little bit of processing, I told myself, oh, you idiot, she didn't want to mention the state of the fact of the day. She actually means, could you bring coffee for me, or could we have coffee? So it wasn't an event that she wants to tell us about something, about the fact in the day, but more it was like a command that she requested something. She expected someone to react to what she said and do some actions, right? So these are usually our commands in our system, and it could happen that we are getting passive aggressive and sending like commands also as an event. But it is important to distinguish between these two things, because for events, we don't care what happens or what other systems are doing with this event. But when we are having a command, we do care who's going to react on that command. We do care that we need something to happen. We need maybe some results to be returned to us. So we should really make a big difference between these two things that we are doing. So after I brought the coffee, then my kids asked me to play chess with each other. This is a match in 1985, which was a great year, by the way, and it is in the World Championship. But I doubt that anyone in the audience, or maybe later on those who are watching the recorded version, know which match it is, right? And I don't think that you could also tell whether this is like the end of the game, or is it the middle of the game, or which state is it, right? Because we just have a snapshot of that game. So this game was between Anatoly Karpov and Garry Kasparov, a World Cup championship between at 985, as mentioned. And this is a state of the game in the middle of the game, right? So how do I know that? Is because I designed the slides. I decided to put this image in here, and I know what happened during this game, right? But someone that just see this do not have these informations, right? Unless they ask me and I describe it. And I realized this is very similar to the traditional ways that we are storing data in our databases, right? We always store the latest state of the system in our tables, right? We always overwrite the previous state. So we lose all those informations. We don't know what happened that we arrived in this state of the system. If there is something wrong, we don't know how does that things happen, right? I mean, yes, we hopefully have logs, hopefully have traces and things like that, and we could go and debug and see what was happened, right? But what if our logs say, I don't know, I don't have those things, right? And interestingly enough, back in the days, those players have two papers, like each of them have a piece of paper that they were writing each piece that they were moving, like the move of each piece on the board that they were moving. So the game was started with e4 going to c5, and then c5, and then the knight f3, and then e6, and so on and so forth, right? And interestingly enough, they were even numbering those moves. Why it was important at that point in time? Because if someone wants to audit the game, they could replay these moves and see what has happened. Were there any violation during the game that was ignored, or where there's something wrong in the game, or where the game was legit and everything was fine, right? And so they could audit the things because they have all the history of the game written somewhere, right? And well, two pieces of paper. That reminds me of high availability, maybe, or something, or replication. So this is very interesting. And more interestingly, someone else could take those moves, could take those history of that match and write a book about them, right? They might be interested into seeing where a blunder was happening, where was the interesting moves. They could even analyze different alternatives, right? And see what would happen if we have done this or we have done that, and how the game would happen. And there could be multiple authors out there that are interested in chess, and they are writing their own books, and they are projecting their ideas about each game, right? So I'm thinking why we cannot, actually not I, but smarter people. So Greg Young actually coined the event sourcing, I don't exactly remember the year, but those smart people thought that why should we throw away the history of the data that we have and not keeping them? Because the days that the storage was expensive and we wanted to go through all those kind of normalization of data, not replicating, not duplicating the data, is gone. We now have cheaper storage that we could just store everything. And data is gold these days, right? You could run a lot of things over your data to have better insights about what's happening in your system. Maybe you want to have a new feature that you didn't thought about them like 2 years ago. So if you have all the data, you could just run an algorithm over them and bring in a new feature. So for that, we need an event store. An event store is a key value database, just like many other databases that we have. If you think about it, a relational database is also having a primary key, and the value is the whole record that is there. But for event store, the key is the ID of the stream of events, like those keyed events. If you remember, they had an ID that we could group all things that are related to each other in one stream of events. So in here, game 1000 has game created, player joined, sell field, and game finished. Another stream might have just game created. Another stream might have just game created and 2 players joined, but the game has not started yet, right? So the event store gives us this capability, and it comes with a couple of features. First of all, it should be append only, because as we mentioned, the events are facts that happened in the past. They are immutable, and we don't want to change them, because if we time travel to the past and we change something, it might collide with the present or the future of the past or whatever, all those bad things could happen. And we also want a way to be able to load a stream of events. So we give it the key, and we want it to be able to return all those events in order to us. It is important. We don't want the order of these things to be messed up and we lose something or having corrupted data. Another important feature that we need is support for concurrency, because if the 2 players are playing simultaneously and they just click on these things, right, squares, we don't want our game or our data or our system goes into an inconsistent state. So it is important to have some sort of support for concurrency, at least optimistic concurrency. Okay, so these are the features our event store needs. And we mentioned, okay, we append events to the store and we want to load them. But what happens when we are loading them? So when we load those data, we cannot just look into the events. Most of the times from these events, we want to create a specific perspective that we call them projections. And based on those projections, based on that state, we want to do something. We want to be able to take decisions whether we could fulfill a requirement that the user clicks on a button and wants something to be happen. Could we fulfill that requirement or not? And this is called stream aggregation. So let's go through an example. Here, for example, consider game 2000. A game is created, 2 players join, and now the first player wants to mark a cell as X or O. So they send a command to us to fill a cell. When that command comes in, some processes is running. Sure, we will talk about optimistic concurrency as well. I'm just seeing a question from guys. So, but give me some time. We'll get there. If not, then at the end, remind me again. I will definitely talk about that. Thanks. So we have this field cell command coming in. We have some processors that in the backend that is responsible for taking care of this, right? So when it triggers, it goes to our event store, fetches all those data that we have. So in this case, a game created, 2 players join, 1 cell may be already filled with X, and then this is like for the O. Here, we consider we have an entity named game, and this entity is the one that holds the current state of the game that is in the play, and we need to construct the state of this entity. For stream aggregation, for each event that is happening in our system, we have an event handler. And this game knows when game created is happened, or when player joined, or when player cell filled, what should be done in this game entity. What should be done. And then afterwards, it could also decide from here on, everything is like a traditional way that we are handling a command or a query or a request or whatever. Here, the game has the latest state. We will see that in the code as well, has the latest state. And then it could decide whether this field cell is a valid request from the user or not. If it is invalid, it could reject the field cell command. If it is valid, then it might expose 1 or 2 events, 1 or more events, and then those things will be published to the event store and will be appended at the end of the store, right? So this is like the whole process. So the only difference is how, so to summarize or to, so the event sourcing is a storage pattern. This is about the way we are storing our data in a database, how we are fetching those data, how we are working with those data. So, nice story, show me the code. Okay, let's go to our code base. If I could bring up my writer. Is the font size fine in the audience or not? Just 1 thumbs up or thumbs down. I could do a little bit zooming and then it would be fine. Okay, I assume when there's no reaction, the font size is fine. Good. So this is my event store. It is an interface here. I implemented it with Azure Cosmos DB, but you could implement it with any other databases that you want. So the append to stream, it accepts, it accepts an aggregate ID and a list of events, and then it appends those events to the end of the stream. And for load events, we have the same thing. So we give the same aggregate ID. Aggregate is a term in domain-driven context. It forms like a boundary about the transactions that could happen, and also ensures that the variance and the business rules and everything around that thing, that entity or that aggregate is, or a bunch of entities, is always valid. So we are not violating the consistency of the data in our system. And then, of course, we need a way to tell our store to now save all of these events to this aggregate that we just gave you. So this is the interface that we have. But this is not enough. We need an event stream. The event stream is something in my implementation. We give it a stream ID. It tells the store to give all those related events to me. And then it tries to recreate or rehydrate or reconstruct, whatever you want to name it, for that entities. In this implementation, we are getting a T, class of T, so it's generic. And then it calls, let's see the implementation, it will call all the event handlers for that entity. Okay. So how it works, here we are fetching the events from the stream. if nothing is found, obviously the ID or something was wrong, so we're just returning a null. If something is found, we are instantiating a new instance of that entity, the T, and then we are calling methods named when. There are implementations that it is called apply or on or rehydrate or anything. It's just like naming convention that you could use. And then this instance knows what to do when this event is happened, right? And to take a look into that, let's go to my application. So describing the structure of the application, it is a tic-tac-toe game. In my domain, I have games, I have players, and for the games, we have a couple of events that we already saw in the slides. So game created, player joined, cell field, and game finished. They are just records with these properties that are needed for each of these events. And then we have a couple of commands that are coming to our system, and they are handling those things, delegating stuff to the game class that we have in here. For example, if a player joins, we are checking who's the player, returning X or O, and then we are raising an event player joined. So this is how the logic is. So we don't have specific logics for player joining the game. It is just you join, and then the event is raised, and then it will be stored later on. But to get there, we want to implement the play command in our scenario. So let me implement the play command. Or before that, let's go to, because in event stream, we are calling the when method in here. So let's go to our game class. I created two files. I'm just using the partial class feature of C# language, just to separate them for the visibility and for like a maintenance for myself. So I have this game.when, and here I'm implementing the when scenarios for each event that could happen for this entry. So if a game is created, we are simply assigning the properties, and then we are instantiating the board cells with empty cell. As simple as this. And if we want to have cell field, it is again just some assignments depending on whether it was the player X turn or whether it was player O turn. It is just doing some simple assignments in here. And if honestly I want to implement everything, you will see that all of these when classes are more or less just mapping the events to some internal state of the aggregate, in this specific scenario, the game aggregate that I have. And the last one is when player joined. This is an interesting one. In these previous ones, we don't have any logic in here. We just have some assignments. You see here we are instantiating just some assignments, but here we have two if statements. This if statement, I want to talk first about this. It just seems as simple as possible. It just decides if the X player is null, it do something. Otherwise, it just ignores those logic and goes to set the O player, which are the internal states in here. But the other if is taking some decision. It checks whether the player X or player O, if they are not null, then it throws an invalid operation exception and tells game is full. Right? It is because a third player maybe wants to join the game. They also clicked on the join game button or something like that. But we already have the two players, right? But this is where we are handling the events, not where we are handling the commands. And if you remember, we talked about the differences between a command and an event. And one of the biggest differences is that we cannot reject an event, because it has already happened. It belongs to the past. We cannot reject an event when we are doing any mapping or any business logic. So this logic should have been actually implemented in the command side of this application, right side. So make sure when you are designing your system or when you're writing these kind of logics, if there are if statements, those if statements should belong to the mapping logic, not to your business domain logic, right? So this is an important thing. We will move this later on to the place that it belongs to. I mean, maybe I could already do that. So if we go to our game class, we have this join method that is regarding that one, and we could put it in here. So if player X is not null, means one player joined, and O player is also not null, means two players are already in, so we cannot accept this join command anymore, and we just reject it in here. So the command is rejected, no invalid event is created in our system, and then the mapping for the event could stay as it is. Let's implement the player play command. Yeah, this one. For now, forget about guard against invalid prerequisites. It checks a couple of business rules for the rules that needs to be applying when playing XO game. And if those are violated, it just throws an invalid operation exception. Let's discuss the rest of the code for now, and then we get into that part as well. So here we are setting some internal state again, and then we are raising an event. So these apply events, if I go to its implementation, you'll see it adds those events that we say, this is now a valid event in our system. This happened, right? So add it to the list of the changes, right? And then that list will be passed to the store to be stored to the event store. So this is a player moved something, or the cell is filled with XO, and then we check after this move, do we have someone who has won the game or not? So some logics, and if it happens in here, if we have a winner, then we are raising a game finished, and we are setting which player won the game and which player lost the game, right? And if that not happened, then we are checking against other rules to see whether the game is finished or not. Maybe the last square in this XO board is marked with X or O, and then we don't have anyone winning the game. So that would be the end of the game. So it just raises a game finished. Implementing this one, let's see how it is implemented. And as you could see in here, it is a series of if statements. Each of them is about one business rule in this game. For example, if the board cell is not empty, it is already filled with some values, right? If it is not your turn, then you cannot play. You need to wait for the other player to fill some cells, and then it's your turn, and you could do that. And this is the implementation for that. Before going further, I would like to show a demo, and then we will discuss about testing, and then we will discuss the concurrency matter, and also like how to do the read side of the application. Because so far, whatever we did is about writing to our event store and writing to our database and writing into our system. So let me switch to Chrome, maybe. Yeah. So if you want to try, I could share the link in the chat with everyone. So I don't know if you guys could see, but if you don't, you could go to xo.shahabtheguy.dev, and then we could play a game together. So 0 to hero, XO game. And I'm creating a new game. And you see, it immediately appears on both screens. But let's join this game from 2 different users. Anyone interested in joining me? Then I'll do the game myself. And here, then we play something, right? I'm just playing them because... and the game is finished. So we see the list of events that happened in here. And if I refresh the page, we still have the game in here. I could join. You could see the state of the game is created. If I refresh this page, the game is still in here, even though the game is finished, right? So let's see how those things are happening. So the first thing is that when I'm refreshing this, oh, the game is gone now, you see. So it takes some time for this list to get updated. This is one thing that we need to talk about. and someone else created the game. Oh, cool. We could join Hamid to play a game with Hamid. Let's see. Oh, the game is already full. You see, this is one of those validation rules that are happening in the system, right? So I assume Hamid is playing now with some of the people in the audience. Let me know who's winning the game. But yeah, if we refresh the page here, we still see the game, but this Zero to Hero game should have been gone. Oh, okay. I'm afraid that no one's listening to me now and everyone's playing games. That is cool. But let's talk about those things. So the first thing I want to talk about is how this active games list is populated. As you saw, as you saw, it takes some time for when the game was finished to remove that game from this list. And if I create like another game in here, when I'm here, because I'm using Signal R, everyone that is connected just immediately see the game. But if I refresh, oh, I was too slow. So sample, let's create the game and immediately refresh. And you see the sample game is not here anymore, even though we have not played that game. And now it appears. This is called eventual consistency. What does that mean? Is that when we are writing to our system, it might take some time for the read part of our application to be able to see that write. And if we don't have any more writes coming to our system, if we don't have any writes coming to our system, those read parts could catch up and being in a consistent state. Let's go back to our code. So how I implemented this feature, I'm using Azure Cosmos DB, and in Azure Cosmos DB, let me just close this part just to have. What we could use is it has a feature called change data capture, and change feed, right? So it gives you a feed that you could listen to, and that feed returns you every document that is written to your in your container. We have implemented here a Cosmos DB trigger, and we are connected to this database, and then we are getting a batch of events that are sent to us as an read-only list of events. Here we are seeing that we are interested just in game created and game finished events. Any other event we are not interested in. And what we are doing here, we are here creating a projection of our system based on these two events. And that projection is something similar to this active game list projection class that I have. And it has a list of available games. So this projection is a document, is a database table, whatever you want to have it, and it holds a list of games there. And the same as our game class that has some when methods for doing something when that event is happening, we have the same scenario in here. So we also have some when methods in here. So when game created happens, we are adding that game to the list of available games. And when the game is finished, we are removing that game from the list of the available games. But since this is asynchronous, this is a process running in the background, and it takes sometimes when we are writing to the Azure Cosmos DB container until the change feed picks that up and the trigger gets triggered and this list gets populated, it takes some amount of time, right? So it's not happening immediately or instantly. So this is asynchronous projections that we have implemented to see that list of things. Yes, we are using C# in this program. It is written in C#, but the concepts are the same. So you could apply the same logics using Kotlin or Golang or Java or any other programming languages, but this is C#. Good. This was for the available games list. But what about when we when we join the game? Let's see if I could join a game. It's not my turn, so I assume someone else was in the game, but let's try something else. Create new game. Let's join that one and join that one in here. When I'm clicking in here, when I'm refreshing, and I'm joining this game again, I want this state to be created again, right? And I want this to be immediate. I don't want this to take some time to be created. So this is different than the available games. This is important that as soon as I'm joining the game, I'm seeing the latest state, whatever it is, right? Because I could click on this, I could hit refresh and the other player plays, and then I'm joining, right? I need to see this, oh, that happened when I was refreshing the page and I wasn't in here. So it is important to be immediate. Let's go to our implementation. So in my application, in here, we have a feature which is load games state. This is a query handler. It should be a query handler, but it is marked wrongly, so this might be a bug. What we are doing, we are getting a stream. We already saw the implementation for that. We get the stream of the events that we have, and we tell the stream to give us the game entity. And then in the game entity, I implemented the two array methods. So first of all, in here, in the get method that we implemented, we are creating a projection kind of for our system. So aggregate is also kind of another projection of the system. It's another way to look into those events and just use them in a way that we are holding a boundary about the business rules, right? So it is more or less the same as the other projection that we had. And then in the two array one, we are just selecting the cells and returning the X and O that is stored in there as the result of this state. This is kind of a live projection. So we do not have any specific projection stored anywhere in our system. We are fetching all the events that we need, and then we are applying those events on an entity, on an object, whatever we have, whether it's an aggregate or another kind of class. And then we are just returning that state. We have that in memory, and it is called a live projection. Good. So far, all of the methods that we saw, it seems that they are just doing some specific business logics and those kind of things. There's no magic going around. And there seems like to be more or less like pure functions that we could just implement and test. And what would be easier than testing a pure function? So let's take a look into cancel. Let's take a look into some of the tests that we have written. So for the features of the games, let's look into the field cell spec. I like to call my test spec because I think these are actually specifications of our system. They are telling us how the system should behave. So that's why I'm naming them specs. Just a taste, right? So cannot play a game without players. Well, of course, this could be a rule. So if we have a game, no one has joined the game yet, and then someone wants to play a field cell. Well, we don't know if you belong to this game, right? So we have three steps in our tests. We have a given state, which means we are considering something to be true. And then we have a when state, which means that when these things happens, then we have a then state. We will see that in other tests. Just stay with me. In the then state, we are asserting the results of what should have happened. So in here, for example, I'm saying if a new game is created, so considering we have a new game and someone wants to play the field cell, we expect an invalid operation exception because no one has joined the game, right? The next rule, for example, we have is play an empty cell. And again, it follows the same pattern. Considering or given, provided a new game is created, two players, X and O, joined the game, and now player X is filling one cell. This is the action, the command that is coming to our system. Now we expect a field cell field event to be happening because it was valid state. Nothing is against that. There's no violation of any business rules that we have. So this is expected to have this cell field. Let's take a look into, for example, when detecting someone wins a game or not. It should be a little bit more complex, right? A lot of business logics there. It should be business logics there, right? So again, the same pattern. Given new game is created, 2 players join, some cells are played, then another field cell command is coming. Then we have a cell field command, because this is detecting someone wins on the first row. So it was the same game that I played live, like that the first row was all marked with X. So we expect 2 things now. We expect a new cell field event that has happened, which is the cell that makes one of the players the winner of the game. And then a game finished with X player and O player as the winner of the game and the loser of the game being there. So you see, no matter how simple or how complex the logic of those kind of actions or commands would be, the tests also following the same pattern. And this is a very good benefit, because even though the learning curve might be a little bit high when we want to use event sourcing, it almost stays at the same level. Unlike the other systems, that when we are creating and adding new features, it exponentially increases the complexity of our system. So these are the things that I wanted to talk about in the code and in the example about event sourcing. So like commands, events, projections, and those things that are taking care of the projections are called projectors, and also asynchronous projections, live projections, and how to test these kind of logics that we have in our system. Regarding the optimistic concurrency, so let me bring up the question in here again. So optimistic concurrency. Let me see if I could draw. I don't have anything to draw, but I try my best to describe it. Considering, maybe I could showcase it in here, I guess. So it is my turn in here, and here I'm trying to do something. I'm double clicking on this cell, and you see the cell is already filled. So the thing is, 2 requests went so fast to my backend service. And the backend service for each of those 2 requests creates one handler, and they are processing the system, right? One of them writes earlier than the other to the end of the stream. That means the second one, when it reads the data, it has, let's say, 1, 2, 3, 4 events in the store when it reads the data. But when it wants to write back the data, there is 5 events in the event store. That means the data is not up to date. The data that I had in my memory, in the cache, is not the one that I fetched before, right? So this write should be rejected, because if this write is also writing to the stream without considering whether it is still the same state as the time that I read the data from it, we might end up in a stale or in an inconsistent event stream, right? I don't know if this answers your question, Said, or not. Let me know. We could discuss it further in detail, and I could try to draw something afterwards if it is possible. And so the other question was, will it be on GitHub afterwards? Yes, it will. Okay, back to the slides. So I created the event store using Azure Cosmos DB, and just to play around and showcase the stuff in here. But I don't recommend that you're doing that in home or in production. There are already tools out there, battle-proof, that you could leverage to implement event sourcing in your production app for your production applications, for your applications. So if you're in the .NET world, there's Martin. In worlds like Java and Kotlin, you could use Axonic, and Emmet in JS world, and current database is also, which was previously known as Event Store DB. It is also a battle-proofed, and they are also having offerings for the cloud and things like that. I think this one is coming in different languages for C#, Golang, and others. Don't quote me on that, but I think they have something there too that you could use. And please go and use these frameworks and libraries that are there, and don't create your own for your production. Of course, if you have to, then that's another scenario, but you could consider these things first when you are designing your system. Challenges, yes, of course, as everything in software, it depends, and there are always pros and cons and challenges. One of the things that we saw is that eventual consistency. If it is not acceptable in your system to have some delay when you have writing something until you read those things, so maybe this is not a good idea to use event sourcing. Maybe it is if you're using different sort of projections, right? So eventual consistency might be something. As our systems usually evolve, it's not that we have a fixed event at the beginning of the software design and then it just stays the same. We might have different versions of that event. Even the meaning of something might have changed, and we might obsolete some events, creating some new events. So these are things that are challenging. How we manage backward compatibility, because as we said, the event stream is immutable. We cannot go and just delete the old events, right? They are there. So to some extent, our code base should also understand those old events and being able to interpret them into the new requirements that we have implemented. Projection rebuilding could be a pain because different things, projections might not be in sync, and all of those things that could happen. But there are also benefits. So if there are all of those challenges, why are we doing these things, right? Because data is gold these days, right? Caching is easier. If the state of the game is not changing at the move 3, I could just always tell every caching system that this is not going to change. Just keep it forever, right? In the cache, you could do that. Events are immutable. Immutability is a great feature that maybe we are underestimating the values of that, because when you have mutable state, it's always hard to understand what happened that we get into this state. We could have side-by-side rebuilding of this stuff. If my application is running, I could try new algorithms over the same event stream and see what would happen, whether this new algorithm is faster or slower than the current one we have, and then we could just compare them to each other. And history is interesting, unless it's my search history, which I'm pretty much sure no one wants to know about it. But history of our system is important. Consider when a bug is happening in the traditional way, we don't even could tell what happened, right? That we have the invalid record in our database stored. But when we have the history, we could actually look into the event store and see the steps that happened, and we get into here. Auditing would be easier. There's a misconception that with event sourcing, you have automatic auditing, but auditing is a little bit more than just storing the history of your system there. So the other two things that for me are important is we could get as close as possible to the real world model that we have, because we are modeling the facts that are happening in our business, and it is really easier to model these things than a lot of other magics that we are currently doing. And we are a little bit free of the restrictions of the data stores about how those data stores work. We just need some kind of documents or relational things to store. There's no kind of magic of all of those ORM mappings and all of those things that we know. We always should be aware of, like n+1 writes or reads, and things like that. So these are really two important things from my perspective. And of course, if you want to try it yourself or see the code base, you could scan this QR code or take a photo of this one. And it has a main branch which has the whole implementation already in that. And then there are like other branches. I think it is called MSFT 0 to Hero or something like that. And then it is the state of the game that we have started this game and implementation from there. And of course, if there are any that in the audience, I highly recommend them not to set Fortnite as a password for any of the systems they are having at home, because it's too weak. And there's also another game named Fortnite, so the kids might be aware of that, and yeah, they might break into the systems that you don't want to. Great, and yeah, get in touch. I'm Shahab. If you want to be connected, follow me, or just let's be connected over LinkedIn and other social medias. I would be more than happy to be sharing the knowledge with each other and discussing all these matters, because as we all should learn new things every day, and probably things that I'm saying currently might be not valid tomorrow. So let's see. I think I'm finished with the presentation in here. Let me see. So there is a question. Thanks for Java version code. Yeah, I forgot, a colleague of mine also. If you go to the repository that I shared, you could also see a link to a Java version of that. A colleague of mine took the effort and created a Java version. So I think I think that would be really valuable to see that things as well. Hamid, I think you were alone in the game. I think there is a bug that we need to discuss about that to see, like, did I have a bug in the system or not? I don't have anything else to share. If there are questions, I would be more than happy to answer any question that is left in the audience.
Awesome. Thanks much. That was an amazing session. I really enjoyed it. Despite I'm not that much of a programmer or developer, but this gave me a good impression of what's happening. I really love the part that you also developed the game. I'm gamer. I love games, so that's why I try to create some new games, and even in there just to play some small games.
That is great. The thing is that when I'm talking to people, most of them say, like, event sourcing is for complex systems and things like that. I agree to some extent, but any system that has some business logic going around that, I think event sourcing would be a great fit for that. Like, for this XO game, there's not that much business logic going around, right? But it helps you just to have a better implementation, in my opinion, and better understanding of the system. So if you have just a normal CRUD-based system, maybe event sourcing is a lot of effort. But if there are like some business logic, some rules that needs to be validated and taken care of, then I think this could be a good fit.
Perfect. I guess you already answered all the questions. If there's any questions, anyone in the session now, we still have time. Okay. Sounds like it's all clear.
Yep. Great.
Perfect. Thanks much for the session again, Shahab. And
Thanks for having
everyone.
me.
Sure. Thanks everyone who joined online. And this session will be available immediately after we end the stream and will be available on YouTube. So I'll definitely recommend watching it again. I'm one of them. Gonna watch it again, definitely. And looking forward to see you in the next sessions. Thank you so much.
Thank you, everyone. Have a nice evening.
Nice evening.